Slide it to the end because it'll be close to 1120. Now we got to examine it.
Oh, okay. All right, so let's get started on this one. We're going to try to find the equation for slope and displacement for this beam. Again, like we talked about last time, if I were to cut this structure at some distance x, you want to work the left side or the right side? Yeah, I think this one's pretty clear. You probably want to work the left side. So when we do that, we're going to want to find the reactions at A. So let me go ahead and pencil in that I want, I'll call it AY and BY, but we won't worry about BY. So I'm going to sum moments about B to find my reaction at AY. To do that, I'm going to first find the resultant force for this distributed load. It's a triangle. Area of a triangle is 1/2 base times height. So 1/2 base L times height W. I should get WL over 2. And the distance from B, where I'm going to sum my moments, what's that? X over 3. So with that, I should be able to find my reaction at AY. So I'm going to sum moments. Oh, sorry. I'm already thinking ahead. So I'm going to sum moments at B. My concentrated equivalent creates positive moments, so the force is WL over 2 times the distance of L over 3. And then my reaction at A creates negative moment, AY times L. So it looks like AY is going to be WL over 6. So then I'll come back, and at this distance x, we'll draw a free body diagram for this part of the beam. So I have my reaction, WL over 6, and then internally, there's my positive bending moment, there's my positive shear force. I'm cutting it at some distance x. What is the intensity of the load right here as a function of x? Basically, I just have to write an equation for this line. So I start off with 0 value, so I just need to know the slope. What's the slope of this line? Rise over run. W over L. So this should be WX over L. When x is 0, I get 0. When x is L, I get W. So that means, oh, hang on, I threw my pen across the floor. So my concentrated equivalent force of this will be 1/2 base times height, so 1/2 base times height. And of course the distance, that's what I was thinking about earlier, x over 3. So let's sum moments. Use right-hand rule for my sign convention, and let's sum those at this cut section. And let's say that make sure they're in equilibrium. So starting with the moment, M, then I have the moment due to this thing. So let's see if I can tidy this up a little bit. This is like WX squared over 2L. That's going to be positive. So the force will be WX squared over 2L. And the moment arm will be x over 3. And then this force creates negative moment, WL over 6 times x. So it looks like my moment expression is going to be WL cubed over 6L minus WL. Something doesn't look right. No, that's right. WL x over 6.
Yeah, it should be plus.
Plus, thank you. Yeah, that's right. Now we can check it. So what's the moment at A? Should be 0. So at when I put x equals 0, I get 0. I also know that the moment at B is 0. So plug in L here, and you get 0. So that looks like it's a good moment equation. So we're about a third of the way done. What do we do next? Integrate. So I'll come over here and I'll say I know that phi is equal to 1 over EI times the integral of my moment. So again, keeping my value for E and I outside as a constant, I'm going to integrate my moment. Here's my moment equation.
In this case, and the previous problem too, you could pull out, since W is a constant, you can pull out W over 6 to make it a little bit simpler.
Yeah, we could do that. You want to do that?
Yeah.
Let me rewrite this then. Why not? So I can pull out the W and I can pull out the 6. So I can have W over 6 EI. So I'm taking the W and the 6 out of each term, so I'm left with, and I'm going to integrate that, so I'm going to have minus x to the 4th over 4.
Can we take an x out?
Well, that would have made our integral a little nasty.
I like nasty.
And then the next one will be Lx squared over 2. Should be exactly the same if I'd have left the W6 in there. Oh! Plus C1. And actually that should be here. Sorry for all you guys out there with pens.
You're getting an L. Never mind. Well, it would be x to the 4th over 4L.
Oh, I left an L out. Right, thank you. I was just looking. I had a 4th order and only a 3rd order there. Thank you. That would have been trouble to find later on. Okay. So now we just plow ahead because we don't know anything about the slope. So we know that the displacement is the integral of slope. So let's integrate this thing. So we still have our W over 6EI. Except now we need to integrate this. So I have minus x to the 5th over 20L plus Lx cubed over 6 plus C1x plus C2. So what are our two conditions? Where do we know the displacement? We know it at A, we know it at B. So that means the displacement at x equal 0, that's A, should be 0. So plug in x equals 0. 0, 0, 0, all we get is C2. So that means C2 has to be... Usually one of these works out like that, really easy and clean. The second one's going to cost us at x equal L, which is at B, the displacement is 0. So again, like we did before, let's take our time as we put in values for L and let's account for them. The W6 over EI, since we're equal to 0, we're not going to be worried about it. So what do we have left? We have minus L to the 5th over 20L plus L to the 4th over 6 plus C1L. So what's C1 equal to? Well, this is really L over 4, right? And this is L over 4. Divided by L is L over, it's going to be L cubed. So I know I'm going to have something L cubed. I've got a negative 20th plus a 6th. So I'm just going to kind of write it over here. What's a common denominator for that? Would be 60. So I've got negative 3 60s, that's this, plus 10 60s, right? That gives me what? 7/60. And it'd have to be negative. So it looks like this is going to be negative 7L cubed over 60.
Nice.
Everybody like that? I don't think you do, but I think it's right. Check me on that. Because this C1 is going to have to go back in here and here. Anybody see anything wrong? Let's plow ahead then. So, we need to plug this back into this equation, and eventually we want to find the location where this is 0. So let's do that. So I'm going to come over here and say that actually my equation for theta is what? It's W over 6EI, and I've got minus x to the 4th over 4L plus LX squared over 2 plus C1, which is actually minus 7L cubed over 60. Do that right? So somewhere in here, this is going to have to be set to 0. So we know that our maximum displacement is going to occur when the slope is equal to 0. So we need to find where the slope is equal to 0. Okay? Let me give you some insight on that. So, first of all, this W over 6EI doesn't matter. We're going to divide through to get rid of that. So I'm going to be left with an equation that looks like this. I'm going to have minus x to the 4th over 4L plus LX squared over 2 minus 70L cubed over 60 is equal to 0. I got to find x values for that. Okay? Believe it or not, that's the quadratic equation. Kind of. Let's see if I can help you make sense of this. Let's see. I'm going to divide everything by L cubed. Okay? So I get minus x to the 4th over 4L to the 4th plus x squared over 2L squared minus 7 over 60. I divided by L cubed. Everybody see that?
You divide by 2 now?
You could, but let's do this first. You'll notice that I've got x over L to the 4th, x over L squared. So I'm going to replace, I'm going to say z is equal to x over L. So this ends up being minus z to the 4th over 4 plus z squared over 2 minus 7 over 60. Now what do you want to do? You said you want to divide by, multiply by something? Yeah. Let's multiply by 4. You like that? Yeah. So I got minus z to the 4th plus 2z squared minus 28 over 60 equals 0. Right? Are you following so far? Now I'm going to make another one. I'm going to say r is equal to z squared. So now I get minus r squared plus 2r minus 28 over 60 equals 0. And there's your quadratic equation. Solve for R. And then take the square root of it, and you'll know what fraction of L that occurs at. Now we can do that. I mean, we don't have time. Class is over right now. But this is not hard. Remember, the quadratic equation, these are just numbers. You can plug it in. You'll get 2 roots. Remember, R has to be between, Z has to be between 0 and 1. So if you take the square root of, if you square Z, you still have between 0 and 1. So you'll probably get 2 roots. I'm guessing one will be negative and one will be positive, and it'll be less than 1. So I might have you finish this problem for homework.
I'm writing it down in my...
So after you solve this equation, you'll know what value of x the maximum moment occurs. So way back over here, you'll plug that value of x in here along with C1, and you'll be able to predict the displacement.
I'm writing down.
This is kind of a rhetorical question. Are there any questions?
Is it too late to change majors?
Yeah.
Yes, it is.